Unfortunately, no one can be told that we take security seriously. You have to see it for yourself. You take the blue pill, the story ends. You change your password and have credit monitoring for the rest of your life. You take the red pill and have your eyes opened, mostly because you'll be looking for that YubiKey you always misplace. And I show you how deep the AppSec goes. Remember, all I'm offering is the truth, nothing more. Which means this week we talk with Dan Guido from Trail of Bits about evolving security testing into a practice that sends attack classes to extinction. In the news segment, the latest Log4j, juicy details on FPGA, threat models for the A in CIA, risks that won't go away, and more. Wait, and the truth, nothing more. Start dodging bullets and stay tuned for Application Security Weekly.
This is Security Weekly, for security professionals, by security professionals. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today.
This is episode 178, recorded December 20th, 2021, 2 days before The Matrix Resurrections comes out. I'm your host, Mike Shima, and I'm not here with Agent Smith, but I am here with John Kinsella. Hello, John.
Mr. Shima. Hey, how you doing? I'm one correction on your intro. I think, unfortunately, a lot of our listeners are already dodging the bullets, so I hope they keep doing that successfully.
Oh, so much Log4j, yes. And we'll have to talk about that more. But we've also got a great guest coming up. So let's get into some announcements and introduce him. John, just in case you were worried, don't miss any of your favorite Security Weekly content. Visit securityweekly.com/subscribe to subscribe to any of our podcast feeds and have all new episodes downloaded right to your phone. You can also join our mailing list, Discord server, and follow us on social media and our streaming platforms. Also, we had an absolute blast putting together this year's Security Weekly Unlocked virtual event. All presentations are now available on demand for your viewing pleasure. Please visit securityweekly.com/unlocked to register for free and watch now. Dan Guido is the CEO of Trail of Bits, a cybersecurity firm he founded in 2012 to address software security challenges with cutting-edge research. He has grown the team to 80 engineers, competed in the DARPA Cyber Grand Challenge, built an industry-leading blockchain security practice, and refined open-source tools for the endpoint security market. Dan also serves as a director at HackSecure, an investment syndicate focused on seed-stage cybersecurity firms. Dan contributes to cybersecurity policy papers from RAND, CNAS, and Harvard, and he runs Empire Hacking, a 1,500-member meetup group for NYC area cybersecurity professionals. Hello, Dan. Thank you for joining us.
Hey there. Great to be here.
You're a busy man, so it's great. We thank you for taking the time to chat with us. And one of the things that really stands out from what you do, from what Trail of Bits do, is that security testing is different. And I think maybe it even goes beyond security testing. And I sort of had the idea to preface this with being an outdoors person. I like the tenet of take only pictures, leave only footprints. And that's important for preserving the environment. But in AppSec, we don't want to. We want to see security testing actually have an impact on the environment, and we want to take more. We want to do more than take only screenshots and leave only vuln reports. And I think that's exactly what Trail of Bits is doing. And one of the things, there's a lot of topics you run into: blockchain services, crypto, endpoint, as mentioned. Start us off on this trail of bits.
Yeah, sure. So. For people that don't know, Trail of Bits has been around for about 10 years. We've been doing low-level security research for most of that entire time. Got our start doing work with DARPA, doing work on compilers, on automated program analysis, competed in the Cyber Grand Challenge, that kind of thing. And I'm trying to, the last 5 years or so, we've built a consulting practice that offers this kind of help to people that are building technology products. And I've been down this road before. I used to be a consultant at ASW Partners a long time ago. and obviously have a lot of experience with the whole industry of people that are kind of like hunting for bugs in software, and that's great. But I wanted to come at this differently with my background in research in mind. And a lot of ways that Trail of Bits works is to eliminate vulnerabilities from the code that we review. We're trying to be a little bit deeper when it comes to finding vulnerabilities, and we're trying to actually leave it in a better space than where we found it. So that usually involves really systematic testing and verification that I don't see a lot of other consulting firms, or really a lot of other security engineers doing.
Yeah, I think that's one of the big things that stands out, is that rather than even just saying, walking developers through, here's how to fix the vulns, here's the recommendations, going back and retesting afterwards, I think, in fact, you would go and do, make some commits for that code base, go in and harden it in with an architectural perspective, as well as you mentioned the idea of formal verification, which I think comes in very critically for cryptography, for protocols as well. So I'm kind of curious, what are some good examples of ways you found that so successful to point to in this idea that you're eliminating vulnerabilities rather than just, going in and trying to mitigate them?
Yeah, sure. So I think it makes sense for cryptography. It's really easy for people to understand that cryptography is very brittle, right? Like when you look at cryptographic code, if you have an error in it, it's usually catastrophic. There isn't really a low severity cryptographic issue. It always turns into something where you can decrypt something that should have been confidential. So the way that people write cryptographic code is they usually have extensive test vectors. They have really low lines of code. They have small code bases that are then easy to apply formal techniques to evaluate to make sure that it's actually safe. But that kind of process around testing and verification hasn't really been used outside of cryptographic libraries that much. It's something that you find in small little cases. Like sometimes there's some verified software that lives inside of your Airbus plane that you're on, or some other like government systems that somebody's written from scratch in Haskell because they had to. But you can't really use those techniques on most real software. It's kind of been stuck in this state where, for the longest time, the best that you could get is really, hey, we've got unit tests on our code, right? Because the code bases are huge. Like if you popped open the hood on Internet Explorer's code base or Firefox's code base or whatever, the state of the art there is, we've got unit tests, feature tests, integration tests, and maybe we do some fuzzing. But I think with Trail of Bits, what we've tried to be is pragmatic around our application of more advanced techniques than that, so that people can get some mileage out of, whether it's static analysis or property testing or symbolic execution, and apply it to things that aren't just cryptographic software.
Yeah, I think, and one of the challenges I imagine must be is that you can't walk up to necessarily any organization and say, let's dive into this advanced, let's go well beyond the unit testing and get into this advanced state, because a lot of organizations out there, unfortunately, are still scrambling with, hey, we need to do asset inventory. We need to figure out even just how do we triage vulns so we can set up a bug bounty program. So I do want to come back to this angle, but that's not to say that you're ignoring the broad swath of, doing good work amongst the AppSec environment. For example, the pip audit recently came out, and that's a great tool for auditing Python environments. So how did that project come about, and how does that tie in and support this other more challenging work that you're able to get into?
Yeah, sure. So I think the point is that all these are fundamental improvements to various ecosystems. Like we're trying to make a lasting impression on the software that we work on. So with we have an engineering team, right? And like that's a critical feature of, I think, a security consultancy, is it's really not enough. Like I think we kind of know where a lot of the bugs are, and what's important is that we have to get to work to fix them. So I'm kind of like tired of a lot of the standard kind of application security consulting work where you just go in, you find some bugs, fill up a backlog, and then come back next year and find all the same ones all over again. So if you want to make some fundamental progress in the industry, there's a couple different ways that you can do that. And it's by showing people how they can use more advanced testing and verification techniques so that they aren't stuck in this unit testing, cycle of death for the last like 30 years. And it's also helping entire communities use things like two-factor authentication, or eliminating the opportunity for people to upload malicious packages to a package manager, or it's fundamentally better understanding of what your software dependencies look like. So we also released something the other week called It Depends, which is what I think is the single best SBOM related tool that exists because it can track down native dependencies. So, our engineering team focuses on that. A lot of the work that we get actually comes from large foundations, comes from large tech companies, and is really focused on open source software. So we've done a lot of work with the Python Software Foundation in particular, although there's a few others out there where, we added two-factor authentication to PyPy. We added API tokens to PyPy. And now we've got pip audit that helps ensure that on the consumer side of things, that not just developers, but on the consumer side of things, that you have some ability to manage your software dependencies. So all this stuff, I really just don't think it's sufficient to simply use the expertise that we've got to go out there and say, oh, you missed a bug. Oh, you missed a bug. Oh, you missed a bug. So we're really into building tools, and we're into techniques. I'm not so much into individual bugs.
I love that.
What's interesting about?
Oh, go ahead, John. Yeah.
What's sort of interesting about that? We had a story on here. Mike? I think it was last week, talking about libNSS from Mozilla. They found even though where I'm going here is, even though that particular library was been unit tested like crazy, Fuzz had, in theory, they're doing all the right things, right, through their CIs. They still weren't testing in an appropriate way to actually exercise the code and find a bug, which someone found there. I think it was buffer overflow. And that's it. What you're saying is resonating with me from the point of view of, we can write unit tests all day and actually show that the code is being covered. But if you're not actually either writing that test with, I'll say, intelligence or finesse, there's a lot more in just saying, oh, we need to have a unit test, or we need to have an auditor, we need to have that. It's how can we take a step back and go, okay, this thing exists. How do we make sure it's secure? So I think that's a really interesting way to look at it.
I think it's really funny that so many people in the security field have a really limited familiarity with the way to talk about verification and the way to talk about software testing. So in general, I think a lot of people are so willing to write off verification as a possible thing to do that having never experienced it or having never worked with it, they think that software is either formally verified or it's not. And they don't realize that actually it's quite a big gradient. When I think about software verification, it's the combination of two things. It's the properties that you have defined, and it's the technique that you use to prove them. And just like regular tests, you can have areas that are highly specified, where you have really good coverage of a lot of the properties that need to be there. And there's also a difference of testing techniques. There's a unit test and an integration test aren't exactly the same thing. The same way that proving a property with a fuzzer or proving a property with abstract interpretation results in potentially two different outcomes. So we've had to review code bases that come to us and they say, oh, this is formally verified, so you're not going to find any bugs, haha. But what you usually do is you end up looking at it and you're like, oh, okay. So all they proved was that it doesn't have integer overflows. They didn't prove that it doesn't have this other class of bug. And you end up finding vulnerabilities in the gaps. So I think a lot of what we've been doing when we consult with some of these open source programs, some of these things that have code checked into OSS Fuzz, for instance, is you look at it and you evaluate okay, well, so they've got a fuzzer running continuously on the code base. How are they generating their corpus data? How do they construct the harness? Where are their entry points? Are they getting stuck at any kind of gate in the program? Do they have a fuzzer mode in their build system? And there's a lot of different things there that just because you're fuzzing the code doesn't mean that you're fuzzing all of it. It doesn't mean that it's reaching all the coverage that it should. It doesn't mean that your fuzzing harness can even detect when something bad happened, that it's going to know about it. With compiled code, a lot of what people rely on is they rely on, well, did the software crash or not? And that's one security property. That's, in verification language, that's one security property. That's a specification, is the code should not crash. There's your spec, right? And that's basically what most fuzzers test. But you might actually want to add 100 other tests. You might want to say, well, did this thing encrypt properly? And can I decrypt it with the right key? And all these other kind of application dependent security properties that then you can feed to a property tester or a verification tool suite and prove. So yeah, there's widespread variance in quality of these things. And one thing that motivates me is helping educate people about how they can do it better.
Yeah, Log4j in particular, JNDI is not causing the application to crash. And I know when Heartbleed came out, I think there was a lot of discussion around OpenSSL. Can it be formally verified? Would formal verification have caught the, just that heartbeat capability within an OpenSSL? And Dan, you mentioned fuzzing on the show here. We mentioned fuzzing for the last 3, 6, 12 months, but you have been looking at fuzzing, I think, in the order of decades. Tell us a bit more about that.
Yeah. So one of our employees, Artem Dieneberg, he had this really funny idea to go dig up some old fuzzing papers, like the original fuzzing paper from like UW back in 1989, and resurrected the fuzzer from the dead and got it to compile again, and then resurrected all the code that they tested it on. They didn't resurrect the code they tested on. They found the modern versions of all the code they tested it on. So like if they tested it on X Windows or whatever, he like found the current version of it in, I think it would have been like 2019 or 2020. And then we reran the 30-year-old fuzzer on it and saw if there were any crashes. And like, lo and behold, yes, the vast majority of bugs that were reported back in 1989 with the fuzzer, that was the first one ever created, still causes software to crash today. And the funny thing is we did this again. So we did fuzzing like it was 1989, then we did fuzzing like it's 1999, which was the same thing, but against Windows, where the open source community, I think, obviously hugely opinionated kind of around like all, many eyes make all bugs shallow, blah, 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 whatever. I'm much more of the mindset that, applied pressure makes bugs go down, right? Like training, frameworks, requirements, right? Like you actually have to motivate people to, take steps to reduce the number of bugs. And Microsoft has wholeheartedly done that since their big TPM memo back in, 2003? So you do the same thing with a bunch of fuzzers for Windows from 1999. And like, again, you get crashes and things, and you probably shouldn't. So, what I see here is I see that the industry, even the best performing people in the industry, are really like stuck. They're frozen in time, where unit tests are really about as far as we've ever been able to get. And it's something that's so impressive, like as a developer, that you would advertise it on a job rec. You would put it up and like recruit people to your company like, hey, you should work here because we actually test everything and we know it works. We don't just ship stuff straight to production from developers' machines with no code review. But, fuzzing is like the new hotness. Fuzzing, over the last like 2 or 3 years or so, suddenly got kind of cool. And now people are kind of dabbling in it. And like, I've never heard somebody pick up a fuzzer and then regret spending the hour or so to learn it. Like nobody like kicks it afterwards. Like, this stupid thing, didn't help me at all. Like, of course, it's like wonderful. It's like the most amazing new software testing technique. But, people's ability to use them is still pretty limited. And it's also not comprehensive, right? There's some haves and there's a lot of have-nots. There's a lot of people in the industry that I think are applying them extremely well. And they're doing it in these very tiny pockets. So I think the opportunity to improve that across the board is huge. So I'm really thankful that programs like OSS Fuzz exist, but like that, at the end of the day, that's really just a couple hundred, open source libraries, whereas your dependency as a person is much more than that. So yeah, the field of testing is kind of ripe for these advances. And I'm not excited about what a lot of people do when they tend to specialize in the security field. Like, there are too many bugs to go out and hand pick and like find them one at a time. Like, we really need to invest in tools and frameworks and in applying them consistently across the board, or else we're going to get nowhere. We're going to get just, bowled over by the enormous quantity of code that gets written every day, and we'll never catch up.
Absolutely. And a lot of that goes back to what you were describing, the work you've done with the with Python ecosystem, just to say, let's actually have two-factor authentication. It's easy to say that could be one of the simple one-line recommendation in a consulting report, but doing the work, actually implementing, is the thing that makes a difference. I'm curious there to also just to highlight other work you've done, because you're talking about the testing, fuzzing, and targeting, where am I going with this? Targeting attack surfaces that are interesting, dependency analysis. We'll have to throw in the "it depends" reference into the show notes later.
Yeah.
There's also, we live in the world of GIFs and images and audio files and video files and all sorts of user-generated content, which are notorious vectors for attacks. We've seen everything from, even just iMessage has been exploited this year, even with their blast doors work on it. And I know you've done some work on how files are handled, files are read. Tell us a bit more about that particular attack surface.
Yeah, sure. So something that's really unique about Trail of Bits is that we straddle the gap between government and industry. A lot of the work that we do comes from DARPA programs. In this case, you're speaking about work we've done on the DARPA AMP program, where AMP is trying to identify polyglots and file parsers and help improve the security of them. So a polyglot or a schizophrenic file would be a file that you can open in two different programs, and it produces two different versions of itself. So think like a PDF that you could open in a PDF reader, but then you can also play it as a Nintendo Entertainment system game, an NES ROM in your NES emulator. And the POC or GTFO kind of zine is quite famous for this. Every single zine always has a different kind of polyglot that's been assembled to make it viewable in like 6 different formats. It's really impressive. There's a guy on my team, Evan Sultanic, who like really takes that to heart every single release. But this DARPA program paid a team of people from Trail of Bits to work on nothing but file parser security for 4 straight years. And we've produced early on in the program really incredible, useful tools like Polyfile and Polytracker, where we can do things like, like syntax-aware diffing. So for instance, if you wanted to diff a JSON file against a different JSON file, normally you'd be limited by what lines things are on. And that's the level of like semantically aware information that you would get. You would get no semantically aware information. But we've got capabilities that allow us to actually figure out what fields changed and by what data in them. And it seems like a simple thing to talk about, but there's a lot of computer science behind it that makes it work. Same thing with Polyfile. So we've been able to very precisely understand the file formats of what documents you're reading. So when I think about the applications to these kinds of things, like there seems to be a massive amount of wasted effort among user-generated content sites and other kinds of, anybody that's got a website on the internet usually has some file upload thing somewhere. They've got an HR staff that has to do nothing but read PDFs all day. They've got, like you said, GIFs, images, whatever, that they have to parse. And every single person sits in kind of like wonder or has a nervous breakdown about the system that is parsing all that information before it reaches a user at their company. Everybody's sandboxing image magic. Everybody's monitoring it to see when it's going to crash. Everybody's fingers crossed that it's not going to get interpreted in a way that it wasn't supposed to. So with this suite of tools, we've got, I think, the internet's best hope at producing reliable file parsers and layering on tools from existing processes and carving out existing parsers and making them safer that people can use right now. And that's just a general cycle that Trail of Bits goes through. Is I have incredible access to funding from DARPA to work on all these sorts of techniques and tools, and then I have the consulting team that tries to give them away to people. And not everybody's the right consumer for it, right? Because sometimes people are trying to figure out their asset inventory. But on one hand, I would say you have to have a portfolio approach, right? Like, so while you're trying to figure out your asset inventory, you also know there's other things that you should be doing too. There's got to be some, low risk, high risk things in your portfolio of projects that you're working on from a security organization. And then also risk is, very much sort of aggregated among a couple of big players, right? Like the joke is that everybody's only got like 7 websites to go to a day. So there's quite an opportunity here to secure a couple of small things that end up being very meaningful to a lot of people. Like you mentioned iMessage, right? Like these are things that are kind of like central dependencies that obviously require some more effort.
Indeed, yeah. And 6 of those sites go down if US East 1 isn't available, right? I think You're highlighting here one of the things I'm, an underlying theme I've been going for in this segment is the idea that let's get beyond penetration testing, just find the vuln, deliver a report, walk away. And you're clearly leading the charge on this. So one of the questions then, how can organizations think to engage you or an organization like you when they say, we do want to do something interesting, but maybe we're either not sure what that is, or what's the type of what's the type of really cool vulnerability, or not vulnerability, what's the type of really cool problem that makes you get out of bed in the morning?
Yeah, sure. I mean, I think so. One way that I would kind of summarize this is I don't like to be paid to find bugs, right? Like, don't pay me to find bugs. Although it's a necessary part of a security program. Like you should do that on a regular basis, but I think people overweight it, right? And they overweight it at the consequence of not thinking about fundamental improvements. Like, okay, this was a survey of the kinds of bugs that we have present in our code base. Let's use this first step where maybe you do a 1-month pen test and you discover, you stick your hand in the barrel and you pull out a fistful of bugs. And now what are you going to do about that? Right. And the process of what do you do about that shouldn't be, oh, we'll have a pen test again next year. It's eliminating each of the causes of those issues and thinking about engineering projects and improvement projects that follow on from it. And that's an area where Trail of Bits is equipped to help. That's an area where, we have our engineering team, we have, verification engineers, we've got testing experts, we've got all kinds of people that can help you fill in those gaps and improve the maturity of your software so you're turning out less bugs over time. Because that's what's going to get you to bug zero, right? The version of inbox zero that you kind of want. So kind of finding a way to get off the testing treadmill. But yeah, so to summarize here, you should pay us to do an initial assessment. Like, generally, that's a good place to start. And then based on the initial assessment, there's no shortage of ideas that our team will have in speaking with any of our clients about ways we can help them do better next time. Because what I would like to do is I would like to get stumped the next time that we speak to you.
Question came to mind there based off the way you were just talking about that. And it's the direct question here, and then I'm going to lead into it. But the direct question is, it seems like it might make sense to educate more a collection of project managers in some of these companies that get your report, right? So think about it. Any of these I've been involved in, either side of the fence. Audit goes through, you have a list of findings. Usually some manager gives that to a project manager, and they're tasked with making sure everything is cleaned off that list. And it seems like if that particular person would have the ability to take that step back again and go, okay, we've got 50 vulnerabilities. Let's see if we can actually make some sense if there's some sort of common pattern going on, how these are, that we can actually go and address that pattern instead of just addressing the particular vulnerability. Does that resonate with you, or is that something you guys do, or have you tried that? Or
yeah, I mean, it starts in the sales process and it ends with the report. And we've got a little bit of a different report template when it comes down to it. Like, all of our reports now have an automated testing and verification section. They have a maturity evaluation where we just come up with our own metric of a couple of different kind of security control areas that help you understand if you're kind of ahead of the game or behind it in terms of, access control management or authorization controls or, complexity management and dependencies, that kind of thing. And our reports specifically describe kind of long-term projects as well as groupings of categories of issues that we found, and help you plan those things out. But this starts way earlier, right? Like when I'm talking to people for projects of ours, a very frequent thing is, hey, at the conclusion of our engagement, we're probably going to find a couple of unique application-specific bug classes in your code. Do you want to build in an extra week where we write some semgrep or CodeQL scripts that directly address these? Then you can plug them in your CI afterward. And usually that's like enough of the drug to get you hooked of like, oh, like you can leave behind something that helps me all year round instead of just waiting for the next PDF report to come out from you. And that's, those two technologies in particular have been points of leverage for us where they're very developer friendly. Much more so than previous iterations of testing tools. They're not like, the fortifies and check marks of old. They're very, easy to learn, tough to master kind of stuff. and they integrate very well into developer test cycles. So usually once you get like one or two people on board from the team, you can educate them. Trail of Bits can like educate them about how they work, and then give them a sample that works on their code base, and usually that's enough to get the ball rolling.
No, that's a lot. Again, there's a lot of work that you're doing in this area that's also out in the open that I think people can learn from. And looking at github.com/Trail of Bits, your Trail of Bits repo has a lot of this research. I think it has some of this guidance as well, and even some, if I'm correct, even some reports that you've worked on that you put out publicly. So and I'm highlighting this because it just builds towards that idea of how do we do things better that you're describing. How do we leave behind a process rather than a list of JIRA tickets? And I think with that in mind, want to maybe switch to looking towards the new year, looking towards 2022. Dan, what are some things that you're excited about to get into research that you haven't either been funded quite yet for, or that you're going after to get that funding, whether it is for DARPA, these long-term types of projects, or if you can talk about them, just some interesting work amongst enterprises or organizations that you're doing testing around?
Yeah, sure. So I think a couple of things that I'm really excited about. First is our cryptography team has been making tremendous progress kind of mastering the field of zero-knowledge proofs. So zero-knowledge proofs, if you're not aware, is a set of technology that allows you to communicate some, like a proof, some information to a third person without revealing your source of that knowledge. So the stereotypical example would be that you could prove to your mortgage broker that you have $1 million in your bank account without giving them a bank statement. That would be a zero-knowledge proof that you could make. Actually, this morning, on the day that we're recording, we have a big vulnerability release and I know I said earlier, like, I don't care about vulnerabilities, I care about techniques, but we use this as kind of like a hook to open up. What we're building right now is the authoritative guidebook for how to write zero-knowledge proofs correctly, as well as code samples for most of the common operations, because it's a very unspecified field. And it's a very high potential field. The whole field of privacy preserving encryption, I think, like most people know about zero-knowledge proofs, multi-party computation, homomorphic encryption, even differential privacy would kind of fit into that, which is just a technique where, in general, I don't want to share all the data that I have with somebody else. I want to eliminate access to it from people that don't need it. And what people are doing is they're using more advanced cryptography now to enable that, so that like the opportunity for just like risk pooling inside of some massive blob of data that's aggregated inside of your company, you can reduce the risk of that whole database getting popped and exposed on the internet by using this kind of modern cryptography, privacy preserving cryptography, in order to reduce the risk of dealing with that. So that whole field, I think, is going to get a boost forward by the fact that we're releasing this documentation and building on it throughout the year, as well as citing some examples of where the industry's gone wrong with a few things. In terms of software like assurance, we're investing a ton in cloud native tooling right now. So I think you're going to see a lot of work from us, particularly with the CNCF and the HashiCorp tool suites, with custom tools to help people use those things safely, as well as foundational improvements to those ecosystems. So things like Envoy, configuration checkers, making sure all those things are tested effectively and they use the most advanced techniques possible to do so. Just in general, our DARPA programs are always going. There's always something crazy going on. We're on a portfolio of about 6 or 8 of them at the moment. So we have a team of about 30 people that are producing research every day. And I would really encourage interested folks to just subscribe to our blog on our Twitter, because they'll get continuous updates about all this random alien technology that we end up dropping out on GitHub.
That is awesome. And for anybody who's just listening and not watching the show, Dan's face just really lights up as he starts to talk about those type of DARPA projects. So clearly they're fun, clearly they're interesting. And as you described, they're giving us a great movement in improving an overall, a fundamental improvement of the software security ecosystem. I'm just going to, we'll keep following that work and keep us posted on all of the cool stuff coming out of it.
It's your tax dollars at work. I mean, this is what the government's paying for. Like, it's a waste for us not to publish it, right? It would be a poor use of tax dollars to not actually put it out there on the internet and try to encourage people to use it, right? Like, we're not just doing this because we enjoy it. Obviously we enjoy it, but like that's not the end goal. The end goal is that this actually has some kind of impact on the industry. So yeah, try it out.
That's awesome. Try it out. And just once again, thank you, Dan, for coming and just sharing a lot of this with us and our listeners. This is a wide range, everything from crypto to formal verification to fuzzing and, very concrete improvements in Python. This has all been great to hear.
Thanks for having me.
Want to thank everyone else for listening. Want to thank John as well. We're going to take a quick break and return with news of the week.